requirements of the bridge. This is a competition in which we are not able to give you leeway on the rules because every class is competing under the same set of rules so that it is consistent across the school. The top 4 qualifiers at HF, no matter the class, will get the opportunity, should they want to move on to the regional competition.
Do they get extra credit?
They do not extra credit. However, I have promised my students the best. If you win the national championship, I will give you an A+ for the quarter.
Wait, so let's say
However, the odds are low, so I'm willing to make that game low. Moving on. So, look at your set of rules, okay? It's important that we go through these. Now, the key rules that you need to read are really not one. In section 1, the materials, the only rule you really need to know is that you have to use these type of sticks. We're providing them to you so I know they're legal. And you need to be using any commonly or commercially available glue. You cannot use tape. You cannot use some experimental glue that you and your dad have been working on for the last chemical formula for 3 years. You have to be able to buy it. Basically, anything you can buy would be acceptable. Okay? So you can use that. Number 2 is 2 and 3 are the most difficult areas, so we're going to come back to those. Number 4 in the back, we're going to use a small block. I have right here. This is the block that is going to hold all of the weight. So on our testing rig here, we're going to have your bridge will be sitting on top. This block slides into your bridge at the loading points, which I'll discuss in a second, and then we will tighten this up so that basically all of the weight will be on this block on your bridge. Okay? That'll make more sense when I draw out the diagram in a second. So we're going to be testing it. It goes through and explains that. The load will be applied by the participant. You're going to spin the disc. Any amount over 50 kilograms will not count. So if you think you're going to hold 50 kilograms or about 110 pounds, you would probably want to make your bridge less weight because that'll help your efficiency. I don't know many people who've gone over 50 kilograms, so I wouldn't be too concerned with it. But at 50 kilograms, technically we stop measuring. And we're judging you on efficiency. So that is how much it holds over how much it actually weighs, the bridge. So if you build a really heavy bridge, it is possible that you could lose to someone who actually held less weight than you because their bridge was significantly lighter. Does that make sense? So it's really a ratio of how much you hold compared to the weight of the bridge. So, you know, a heavyweight fighter might be, or a heavyweight lifter might be able to lift a lot of weight, but compared to their body size, a lighter person might be able to be more efficient. So that's what we're judging on, and the equation is given there. And then the qualification, really your teacher, or all the teachers we're testing on December 7th, are going to have one of these diagrams that all of us have on our desks. It has like we're going to put your bridge down to make sure that it fits all the qualifications. We're going to mass it using a balance that's accurate to the nearest 100th of a gram, and then we will write that down and keep track of every result in a Google form so we can see who the top qualifiers are and where everyone placed in the whole school. Okay, so you'll be able to see, like, out of 150 people or 200 people, how many end up doing it, where you place. So I'm going to draw the diagram out on the board because it's kind of complex. So we're going to read through this sentence by sentence so we can we'll make sure we know what we're doing. So first things first, we are basically trying to clear a canyon. So here's the canyon. The canyon's width, so the distance between here and here, is 300 millimeters. I'm going to do everything in centimeters just to keep it, we're a little bit more familiar with centimeters. So you cannot build a bridge that is less than 30 centimeters wide. Otherwise, it's not going to work because it will fall in between the two canyon walls. Does that make sense? Okay. It cannot be any longer. The maximum length is 40 centimeters. It cannot be any longer than 40 centimeters. Here's a tip. I don't recommend making it exactly 30 or exactly 40 because then it's going to be like, oh, it barely fits on there, or there's like a little shaving that's going over the edge. I recommend keeping it somewhere around 35 to 38, okay? Because then it's long enough where you're actually making it over the wall, but it's not too short where it's sliding in between. right? If you make it exactly 40, maybe you mess it up and it's 40.1 and now it's illegal. Does that make sense? So give yourself some leeway. I recommend going somewhere between 35 and 38. Okay, so that is the lengths, how long it can be and how long it must be. The other thing that we want to talk about is mass. The maximum mass is no more than 25 grams. This is the most common trip up for people when building a bridge. They will build a bridge that is 27 grams. No matter how much it holds, it does not matter, it is an illegal bridge. So what happens is they come in, they bring in a 27 gram bridge that they spent all this time building, and they now have to rip sticks off of it with their hands in class in order to get it legal. In which case it will not be anywhere near as strong as it could have been if they had built it underweight to begin with. I massed out a set of sticks earlier. All of the sticks combined are about 25 grams, without the rubber bands obviously. So if you use every piece of that stick, it would be the full weight. The good news is you only need about half of those in order to do it. So the wood's probably going to be somewhere around 10 to 12 grams, and the rest of it's going to be glue. So it's important that we're efficient with glue. Don't just start gobbing it on. And I'll show you some examples in a minute of people who are good with it and people who are not. Okay, so no more than 25 grams. Also, you cannot have a bridge that is greater than 18 centimeters. That's pretty tall of a bridge. So if we were to look, we get a meter stick. If we'll do it above the testing thing over here, 18 centimeters would be this tall. Really at that point, you're not being very efficient past that anyway. Like when you look at a bridge, it's usually very long in comparison to its height. If you're building like a big box bridge, it's probably not being very efficient. So you can't go over 18 centimeters. You also cannot build it any wider than 70 millimeters or 7 centimeters. So the maximum width, I can't really draw it on here, but we'll draw it like this. The maximum width is 70 centimeters. 7.0 centimeters. Let me redraw that so it doesn't look confusing. So it can be no wider than 7 centimeters. If you make it too narrow, it's going to be a problem because think about a bridge that's really tall but really thin. It's going to be easy to tip over, right? So you want to build a good base, but 70 is probably too wide. So that's where you have to kind of design where would be a good efficient amount of width.
And you need to be able to fit in that wood block. So
Yeah,
if it's
so
too
it has
narrow,
to
that
be
wood block won't fit
Pretty much
in.
it should be at least 4 because that's how wide the block is. So we'll get to that in a second. Okay, this year's rules, something that's particular to this set of rules this year is that there is a no man's zone or an area that you cannot build. Fill it in with red. There's an area in the middle that you cannot build in. So it is 16 centimeters long and it has 6 centimeters tall. So it looks something like this. With the dimensions. This is 16 centimeters long and 6 centimeters tall. And it is centered in the bridge. Nothing can be built in that red area. Nothing. The reason is this year's rules say that this block must be able to slide underneath. This is not the best example in the world, except this is kind of a similar shape maybe than what you could build. Essentially, this block must be able to pass underneath that. So the bridge has to be able to go up over the block and then back down. Do you get the idea? So this must be able to slide underneath the bridge. We are physically going to have, each teacher has one of these blocks that you can test it out in advance. And also the day of it, the test, we will have this block on our diagram, and then we will be able to place your bridge over it to make sure it qualifies. Okay? So that's with regard to the no man's zone or whatever. You can't build inside that red rectangle. In addition to that, the loading points. Okay, this is one of the most complicated things with people that mess up most often. They don't understand the loading points. The loading points, there are 3 of them. Dead center, here, oh sorry, that's not wrong. It's 6 centimeters over. And then, so these are 6 centimeters on both sides. And between, this is straight across, between 6 and up to 8. You must have a location in order for us to place the block. So that little square block, which I threw in here, this must be able to be between 6 and 8 centimeters up at one of those 3 locations. So let me show you what that looks like on a past bridge. So this year's bridge, it didn't have to be up at all, but if you notice, there are 3 locations in which we are able to set this block. That would be one of them. It's actually a person who probably had a legal bridge because it doesn't look like it was very good. This one would be in the middle, and this one would be on the end. However, your bridge, it must be 6 centimeters up. So that means that you would have maybe one loading plane there. So what you'd have is, you have to be able to get the rod up through your bridge, through there, and that's where we'll tighten it at. So all the weight is basically being applied to one of 3 locations. 6 centimeters to the right, dead center, or 6 centimeters to the left. Really, all you have to do is make sure that there's like a shelf there that can hold this block. You don't have to really design it much differently than that, but you have to have it at least 6 to 8 centimeters tall. Let me show you on the diagram. So this dark green line here, that's the horizontal loading plane. So this block has to be able to sit somewhere in between 6 and 8 centimeters, and at the center, here, and here. There's 3 circles at the top. So imagine looking down on your bridge like this. I should be able to, this one actually did on one side, had a good idea. You should be able to see through your bridge to those circles. Because that means that that rod can make it all the way through the bridge, right? Otherwise, if it runs into sticks, it's like, how are we going to test your bridge? That rod has to be able to go up through the testing thing, through your bridge. So imagine I should be able to do this at those locations. Otherwise, I'm going to run into a stick and it's not going to work. Okay, that's the most complex part. Are there any questions about that particular thing? You're going to have more. I encourage you to, when you start building it, or you just draw it out, feel free to bring it into your teacher and then, hey, does this look okay? Here's what I plan on doing. We can't help you design it, but we can steer you away from that's not going to work.
So 6 centimeters from the center?
So the width-wise, this is 6 centimeters this way from the center hole to that one, and then 6 centimeters to that one. And the height of that from the ground, or like the canyon height or whatever, is 6 up and 8 up.
You're going to test all 3 locations?
We're going to test one location. Every bridge will be tested at the same location. We will not tell you until the day of. So when you bring it in, we will make you actually, when you show us, we're gonna write L on there. So like this is the left end of my bridge. So if we decide to do the left one, we know which side to do it on. If you say the right one, we'll know it's the farthest from the left. If it's center, it won't really matter. But this is to prevent, basically, people will build bridges that are lopsided, that one side's crazy strong and the other side's very weak. So that's to prevent that. You'll have to identify which side is left and which side is right.
So we need 2 shelves?
Oh, 1. No, so the 6 and 8, it must be between there. So it could be as low as 6 centimeters or as high as 8 centimeters.
Okay, I got you.
Is there an advantage to having the loading thing lower or higher?
Well, you can't build in that red box. So the sticks have to go at least as high as that. So no matter what, you're probably not going to be able to do exactly at 6 because that means it would be sitting on nothing. Does that make sense? So really, you're probably going to be closer to 7, maybe up to 8. There's probably not a super strong advantage other than don't build it so it's super close. Like if you build your bridge and like right here, you can't build above it. In the top of this, if you make it exactly 6, what if you mess something up and it's 5.9? Now you're over that red box and you won't be qualified. So you should give a little bit of space on all sides of that box. That's how you can get into legal bridge pretty quickly. So here's how I would design it. Here's how I've done it in the past. Do you know 11 by 8 or 17 paper? It's like the big sheets of paper. Okay, so I recommend getting a sheet of paper, using a ruler and drawing it out to scale. So you draw out a bridge. Now what you do is you want to build 2 identical sides. So how do you build 2 identical sides? You get wax paper. Wax paper are like what you would cool cookies on. It's like kind of see-through and like what? It's waxy, I guess, wax paper. So what you do is you tape that over and you glue your sticks on your actual diagram. But you got wax paper between it to protect the actual drawing. and then what you can do at the end, it'll actually just snap off. The glue will easily come off the wax paper, and now you can build an exact identical replica, another one. So now you've got two identical sides. Because imagine having two legs that are different lengths. Like what's going to happen, you're going to wobble around because they're not equal. So building your two sides identical is important. So you draw out on a big sheet of paper to scale your design. Then what you do is you put wax paper over the top, with tape it down to the table, and then build your actual like cutout pieces, make sure they match up to the line, glue them all together. It's all sitting flat on a piece of, on the table, so it's easy. You glue them all together, wait for it to dry like an hour or so. You can actually easily like snap it. It's snapping it off because the glue's going to release from the wax paper pretty easily. If you do it right on the paper, number one, your drawing's ruined. Number two, it's going to actually ruin, like paper will be stuck to your bridge. It's going to look messy. It's going to be extra weight you don't want too. So that's how I would start building it. How do you design it? Well, if I'm sitting like this, there's lots of things you could do. So you could build, and again, these are all just kind of hypotheticals, but you could build something that goes up like this, straight across, and then down. And really anything you do, you could build it straight up, you could build it straight across. You could build it, instead of like that, you could build it at an angle, like that. Really anything that makes it over that bridge, you'd be fine. So either of these sides would be, acceptable, however you wanted to build it. The design's really up to you. There's no limits to the design other than the parameters we gave you. But draw it out. Make sure it's to scale. Make sure it fits everything, and then you would actually take a stick. Let me show you. If I was doing it, obviously this board is not to scale, but I would take it, I'd put it on there, I'd measure where it's at, snap it off. 19 cents down the toilet. Okay, so we're gonna then put it on here, and then you could actually then glue them right together on your picture. Does that make sense? It's gonna be, instead of you measuring it like, oh, make it 1.8 long, that's not gonna work well. Okay, what can you cut these with? Now I broke it, but it's not very flush on the end. So you want to use like either a razor blade from an X-Acto knife. Your parents probably have an X-Acto knife somewhere in the house. You could use a pair of scissors. Now scissors are not going to be as clean, but it'll definitely go through this. You could break it and then use sandpaper, but remember you're making it a little bit shorter when you sand it. So make sure to take that into account. When you glue it too, I'm going to draw this. So let's say you want to build one stick that goes this way, and then you want to glue a stick like that. So what you want to do is you're going to have, I'm going to do red for the actual stick. You got one stick sitting down here. You want to actually cut the other stick on an angle. So this top stick right here, notice in this area that the stick is actually cut on an angle. So you'll actually cut this stick at like a 30 or 60 degree angle. Because then what happens is you'll get a lot of surface area. What you don't want to do is you don't want to take a stick, not cut it, and try to glue it like that. Because look, there's no surface area. The glue's not going to be able to hold. So what you would do is you would take a pair of scissors and you'd actually cut it like that. Now, it would actually be, if you were to lower that, it would be flush to the thing. You'll get a lot more surface area. It'll be stronger that way. Also notice that I'm putting the stick on top of it. I'm not gluing sticks. I'm not gluing sticks side by side. What'll happen is, the glue is the only thing holding that, it'll break. When you glue it on top of the other one, the actual weight of it's like pushing down, like gravity's actually helping you hold the sticks together. So that's gonna be a lot stronger putting it on top rather than putting it side by side. So you don't wanna glue it like that. You wanna take this end, cut it at an angle, and then stick it on the stick. Use glue. Here are the glue I would recommend personally, even though other glues have worked just as well, is from the hobby store. It's called Tacky Glue. It's in a brown bottle with a white top. You've probably seen it before. Super common. The reason I like that is because number one, it's got a nozzle, so I can get very precise amounts of glue. Also, it dries relatively quickly, and it's strong enough for what we're using. The other alternative I would recommend would maybe be wood glue. The problem is wood glue typically has like a large nozzle, and it's hard to kind of keep track of. that's it. I mean, that's pretty much it. The rules are well outlined. I would really recommend you drawing it out, bring it into your teacher and show your teacher, because we've done this more than you probably have. We can look at it and say like, okay, that looks good, now just build it. So, draw it on a piece of paper, put wax paper over it, build two sides, wait till they're dry, then do the cross bridges in between the left and the right side. Yeah.
When you do it across, how would you do that? You do it,
So like I would put sticks, like let's say I have two sides, I would put a stick like that on one side and like that on the other side. So let's say your bridge you want it to be, so his question was, how do I make sure that my bridge, how do I glue the side pieces? So here's what you could do. Let's say you've got one side that's like here and one side that's here. You want your bridge to be straight and not like this, right? Because that's not going to be as strong. So what you could do is okay, this is, let's say, 3 centimeters wide. It should be bigger than that, but let's say 3 centimeters. Cut like 20 pieces identical length, and then everywhere it goes, they'll be the same size. So now I have like a set length as opposed to measuring them every time and not being able to compare. Just cut like all of the same pieces all at the same time, line them up, make sure they're all equal length, and then start gluing them in. Yeah.
and for the loading area, like where you put weight, do you do the same thing? Or would you?
You're gonna, so your bridge, and let me start again. Here's the sides of your bridge. 6 centimeters up, 6 centimeters up. You're gonna put sticks across. This is kind of like a 3D picture, but like you're gonna put one there and one there, so that the bar can go up in between those two. And that's your loading plane. So that's really, you're not gonna have to worry about that, other than the fact that you need somewhere to put those sticks. Like you need somewhere to glue those on. So imagine the sides, make sure I would put something at like that 6.5 centimeter mark so that your other sticks can then rest on top of it. So like at 6.5 centimeters I've got a stick, this stick will then glue on top of it, and this is where I'll rest that block. Make sense? It's complicated, it is. But this is reading the directions. Ask us as your resource, we can absolutely help you guide you the right way.